The idea of this question is you're constrained by a budget of $12,000, and every observation to put these brakes on each car model and test them, every observation is going to cost you $100. So your job is to decide if there are sufficient funds to estimate the mean stopping distance to within 2 feet of the true mean stopping distance with 95% confidence. So what this is about the sample size. So do I have enough money to get enough observations so that I can get the margin of error down to be within 2 feet? So the answer is no. And here's one way to do the question. So there are enough funds for a sample size of 120 cars. We can take the $12,000 divided by 100. So the best that I can do is 120 observations. So the simplest thing here to do is just to find the margin of error for 120 observations. Now the nice part here is we are given a value for the population standard deviation. So we can put in that population standard deviation and divide by the square root of 120. That's the square root of the sample size. This is the formula that we're using for the standard deviation or for the standard error because this is a question about means. But because we know, or at least we've assumed a value for the population standard deviation, we can use a z-score here. This is the z-score for 95% confidence. Again, I assume that you recognize that z-score by now. For 95% confidence, we're keeping the middle 95% of the sampling distribution. That means we're getting rid of the outside 5%. That's 2.5% on each side or in each tail. So I presume you know by now that you can calculate this using the inverse norm command. So the area, the simplest way to do this would be to enter an area of 0.025. That's the 2.5% that we have in each tail of the sampling distribution. There's the 1.96. So literally, if we just find the actual margin of error, this is the best margin of error that we can do with our sample size of 120. That margin of error is plus or minus 2.15 feet. Well, that doesn't accomplish it. We want to be within 2 feet of the true mean. The best we can do is be within 2.15 feet. So no, we do not have sufficient funds to get that margin of error to be less than plus or minus 2 feet. The best we can do is be plus or minus 2.15 feet. I suppose there's an alternative way that you could answer this question. You could use the formula backwards in order to find the sample size that you're going to need to get a margin of error of plus or minus 2 feet. So we could calculate it alternatively that way. So we could say, I want a margin of error of 2 feet. So my actual margin of error will be found by taking the critical value, that's the 1.96, times, again, in this case, we have the population standard deviation of 12 that we've assumed. We can divide by the sample size that we're trying to find. So in other words, now we're trying to find the sample size that will give us that margin of error of plus or minus 2 feet. Fine. So I'm going to solve this by ignoring the plus and minus. It won't make any difference. We'll divide both sides by the 1.96. That gives us this. So again, I suppose probably the simplest way to think about this is to cross multiply. So you have 2 times the square root of n. That's going to equal the 1.96 times the 12. So divide by the 2. Then to find your sample size, we'll square both sides. So you have the 1.96 times the 12 divided by the 2. And that quantity we want to square. There we go. So we're going to square the quantity 1.96 times the 12, divide by the 2. That I want to square. That gives me a sample size of 138.2976. Now, that is not the final sample size that you would want to report. That's not the final sample size that you would want to report, because at this sample size, you should always round up. So what we really require is a sample size of 139. That's what's needed to get the margin of error to be within 2 feet of the true population mean stopping distance. But then understand, to answer the question, you're still going to have to go back and use the 100 and the 12,000. The 12,000 divided by 100, that's the 120 observations. I need 139 observations to get within 2 feet of the true mean. The problem is that that 139, that's more than the 120 that we can afford. This is what we can afford. This is what we need. So it would be good to include this comparison in your answer. No, the reason that sufficient funds are not available, we need 139 observations to accomplish this, but we can only afford 120.